Hi, welcome back. We are moving into chapter 2. And chapter 2 is the chapter in which we'll talk about measures of central tendency, and we'll also talk about measures of variability. But in this video, I'll just talk about measures of central tendency. There's 3 measures of central tendency, and those are called the mean, the median, and the mode. And we'll talk about each one of those in this video. So in general, central tendency is a way to make sense of a group of numbers. So once we have all that data in front of us, we have all of our sample scores, it's sometimes hard to make sense of it when you're just looking at a big jumble of numbers. So measures of central tendency allow us to summarize the numbers into a single score or a single number. This is important because it allows us to describe a whole set of data using a representative value. And there are different ways that we could think about representing the data. That's why we have 3 different measures of central tendency. So in this video, I'll talk about the mean, the mode, and the median. And I'll start with the mean. The mean is a measure of central tendency that you're all probably very familiar with. Sometimes we call the mean the average. Sometimes we use those synonymously. And to calculate the mean or the average of a set of scores, we first add all the scores up, and then we divide by the number of scores. So this is the formula for the mean. And we use capital M to denote the mean. And you see that we have on here something that looks like a capital E kind of. That's the Greek letter sigma. It's big sigma right here. That's big sigma. And what sigma means is the sum of. So anytime you see anything after a big sigma, it means you're adding those things up. So we're taking the sum of X. And X in statistics usually refers to a set of scores. So we're adding up all of the scores in our sample for this variable. And then we divide by N. And N is the symbol that we use for the sample size. And here on the right side here of the slides, you see all of those definitions. So M for the mean, the big sigma means the sum of, and X refers to the scores in the distribution of variable X, and capital letter N is used for the total number of scores in a distribution or the total number of people in your sample. We can think of the mean as being what would be the balancing point on a scale if you took your histogram and then balanced it on top of something round, something cylindrical. So the mean would be the balancing point in the data. You can see that the mean doesn't have to be a whole number, and you probably know this from your own experience. When you calculate the mean, it can be a decimal point. And you can see all these different examples of distributions with different values of the mean. You can see, maybe if you take a second to look at these, you could pause the video, that the distributions that have values way out in the tail actually get pulled down a little bit by those values out in the tail. And generally speaking, otherwise, the mean seems to be centered around the most data in your data set. All right, let's move on. The mode is another measure of central tendency, and the definition of the mode is that it's the most frequently occurring score in your data. So you can think of the mode when you've made your histogram, after you've made the histogram, as the highest point of the histogram. So the highest bar represents the mode of your data. And importantly, there can be more than one mode. And you know this from the last video lecture where we talked about bimodal distributions. If there's a distribution, or you create your histogram and it has 2 clear peaks, that means it has 2 modes. And that if they literally have 2 modes, then it means that there are 2 scores that tie for the highest frequency. And that would create a bimodal distribution. So here in this example, you can see that the most frequently occurring score, or the highest bar in the histogram, is over the score 8. So the mode for this example data here is 8. 8 is the most frequently occurring score in the distribution. And finally, the last measure of central tendency that we'll cover in this video is the median. And the median, by definition, is the middle. So it's the middle score once you've sorted the scores from the lowest to the highest. So you take all your data, you sort it from lowest to highest, and then we need to find the middle point in that list. And the exact middle point is the median. So in other words, you could think of this as the point or the value for which half of the ordered scores are lower than it, and half of the ordered scores are higher than it. So let's look at an example. If our scores are 1, 1, 3, 4, and 5, each one of those scores represents a value for an individual in our sample. Then we ordered them. Notice that they're in order from lowest to highest. And the middle, you see, first score, second score, third score, fourth score, fifth score, right? This is the middle score. So the middle score, once we've ordered our scores, is 3. So the median of this data set is 3. That's really straightforward. If you only have 4 values or an even number of scores, then notice that the middle will be between 2 scores. So the middle of these 4 scores is between 1 and 3. So the middle being between 1 and 3 will be the average of those 2 scores. So we take the average of 1 and 3 to get a median of 2. So I hope that's clear. If you have an odd number of scores or one clear middle point, then that's your median. If you have an even number of scores, then the middle of your list will be between 2 different scores. And what you have to then do is take the average of those 2 scores on either side of the middle to get your median. The challenge of calculating the median by hand when you have a long list of numbers is in finding the middle score. So the book recommends, and I go over here, some steps for finding the middle point. So the first thing that you would have to do is figure out the position of the middle, and you do that by adding 1 to the number of scores and then dividing by 2. And that will tell you the exact middle point of your list of scores. For example, you could imagine a list of 10 scores. So we have our number of scores is 10. We'll add 1 to that. We want to add 1 to the number of scores. So we do that here to get 11. Then we divide that by 2. So 11 divided by 2 gives us 5.5. So that tells us that the middle score in our list of scores is the 5.5th score in the ordered list. Or in other words, that the middle of our list of numbers is between the 5th score and the 6th score. So if you have a lot of values, a lot of scores, or a very large sample size, then this would be a quick way to find the middle point of your data. So let's look at a little example of the median, because this one is the one that takes some time to catch on to for some people, or at least some practice calculating on your own. So let's imagine that we asked 10 people to report how many dreams they have in an average week. And remember, we have to sort those scores from lowest to highest. So we sort those scores 1, 3, 3, 6, 7, 7, 8, 8, 8, and 9. Those are the number of dreams that people reported. We sort them off from lowest to highest, and then we find the median. Okay. So there's 10 scores. Our middle point is the 5.5th score, or between the 1st, 2nd, 3rd, 4th, 5th score and the 6th score. So our median is right in the middle there. So our median is the average of 7 and 7, right? So to calculate a mean, remember the average, you add those up and divide by 2. Divide by the number of scores that we're adding. So 7 plus 7 divided by 2. This should be pretty intuitive for you, but just to make sure we know, is 14 divided by 2, which of course gets us 7. So in a normal distribution, which we learned about in the last video, remember a normal distribution is unimodal, it's symmetric, and it's approximately bell-shaped. In a normal distribution, the mean, the median, and the mode will all be exactly equal to one another. They will all be identical. But in a skewed distribution, the mean gets pulled towards the tail of the distribution. So those really extreme values, the people that fall out in the tails, either the low tail or the high tail, those values pull the mean towards themselves. So you can see in a negatively skewed distribution, right? This is negatively skewed because the tail is on the left. So in a negatively skewed distribution, the mean will be to the left of the median, and the median will be to the left of the mode. The mode, remember, is just the peak of the distribution. And in a positively skewed distribution, those extreme values that are way out in the tail pull the mean towards the tail. So the mean is to the right of the median and the median is to the right of the mode. The mean is the measure of central tendency that you will notice we'll use the most in this class and in general in statistics. And there are some reasons for that. The mean is the most stable measure of central tendency because all of the scores in the distribution are included in its calculation. So every bit of information from our data goes into the calculation for the mean. If you think of it, right? We added up all the values and then we divide it by the number of scores. So all of the information we have goes into that calculation. That's not true for the mode or the median. Also, the mean is not as affected by the addition or deletion of scores. So if one person were removed or we added one person to our sample, the mean won't vary very much. But you notice that if you did do that, if you took someone out from your sample or added a score back into your sample, then the mode or the median could be greatly affected by that process. And because of these things, the mean is used in many of our statistical procedures. It's such a stable measure. So you can see here that we have a summary slide that shows us that we've talked about 3 different measures of central tendency. We talked about the mean, the median, and the mode. And this table is a really neat table that shows you when we would use one of these measures of central tendency over the other. So I've mentioned that we use the mean most commonly in our statistical measures, and it's really valuable when you have numeric data. But when we don't have numeric data, then we can't calculate a mean. So if you think about categorical variables or nominal variables, those you can't add them up, right? You can't add up all your values when they are flavors of ice cream, right? If your favorite flavor of ice cream is chocolate, vanilla, strawberry, and so on, we can't add up those values and divide by a number to calculate a mean. So we're out of luck and we need to use a different measure of central tendency. In that case, we would most likely use the mode, or the most frequently occurring or most commonly reported favorite flavor of ice cream. And we also don't usually use a mean when we are working with rank ordered or ordinal variables. In that case, we are most likely to use a median. I do have an example here in this lecture. So let's move forward into this example of different measures of central tendency. And this example will look at whether the CSU system is successful in its mission to offer a high quality of education at an affordable rate. And we're just going to look at if students graduate in 4 years first. Let's just look at some figures if students graduate in 4 years. So the current tuition, this might be a little bit outdated, but the current tuition at Sac State for a year would be $5,472. So if you multiply that by 4 years, that means over the course of your education, you pay about $22,000. In comparison, if you go to a University of California, Davis, then you're paying about $13,456 per year. So if you graduate in 4 years, you're spending a total of about $53,000 or $54,000. Okay. You might be asking yourself, but what if you don't graduate in 4 years? So let's work through an example. We actually wanted to ask a group of students, 10 students in this case, so our N is 10, with degrees from Sac State and UC Davis, how many years it took them to graduate. So you can see here that we have 10 individuals from Sac State, 10 individuals from UC Davis, and we have a score for each person that represents the number of years it took them to graduate from their institution. First, let's calculate the mean time to graduation for each of the universities. So remember, I have the formula here for you. I'd like you to get used to looking at these formulas. The formula for the mean is the sum of X over N. So we need to first sum all of our X values or add up all the scores. Okay. So you'd add 4 plus 5 plus 9 and so on. And then what are we dividing by? We're dividing by N, and remember that N is the sample size or the number of scores. In this case, if we want the mean for Sac State students, then we have 10 Sac State students. So N is 10 for that calculation. So you'd add up all the Sac State scores and then divide that number by 10. So first here, just the sum of the scores, right? I did that in that column separately. So if you add up all the scores for the Sac State students, you get 57. And if you add up all the years to graduation across all the 10 UC Davis students, we get a value of 43. So each of those has 10 students. So we divide by 10 in both cases to get a mean time to graduation for Sac State students of 5.7 and a mean time to graduation for UC Davis students of 4.3. Okay, let's move forward and calculate the mode time to graduation. So the mode time to graduation, remember, is the most frequently reported time to graduation for that group. So if we want the mode time for Sac State students, then we want to find the value that was most frequently or most commonly reported. I have a note here that if you reorder the scores, it can make it a little bit easier to see the mode without making mistakes. So I reordered both of these rows, and you can see that for Sac State students, there's this chunk of scores, this chunk of people who all reported that they graduated in 5 years. Right? So that's definitely the most frequently reported value for Sac State students, so the mode is 5. I'll give you a second to look at UC Davis and think about what you think the mode for the UC Davis students is. Hopefully you identified that the mode for UC Davis students, the mode time to graduation, is 4 years. Okay, now let's move on to calculating the median. So the median time to graduation. We've already ordered all the scores to derive the mode. So now the next thing we need to do is find the middle point in our list. So you could probably do this pretty intuitively. We know that the middle point is going to be that there's 5 scores on this side of the middle and 5 scores on this side of the middle. Right? So you know that the middle score is going to be between the 5th and the 6th score. But if you wanted to do that using the steps that I've given you in the video or that they offer in the book, then we would have to take the number of scores. There's 10 scores, add 1 to that, and then divide by 2. Okay, so 11 divided by 2 equals 5.5. So that tells us that the middle score is between the 5th and the 6th score, as we already derived. So the median time to graduation for Sac State students is the average of 5 and 5, which of course is just 5. And then the median time to graduation for UC Davis students is the average of 4 and 4, which is a median of 4. Okay, so let's just summarize. We've calculated the mean time to graduation, the mode time to graduation, and the median time to graduation for Sac State and UC Davis students. And then I also put some histograms on the screen for you to display, or for you to look at and to get comfortable looking at. So you see that the years to graduation at Sac State on average was a bit higher than the mean time to graduation at UC Davis, and also the modes and the medians are a little bit higher for Sac State students. So what does this tell us about affordable education opportunities at Sac State? It tells us that students who take 5.7 years to graduate at Sac State are still spending significantly less money on their education. So even if we take into consideration time to graduation, on average, students at Sac State spend about $31,000 on their education for 5.7 years, right? And students at UC Davis spend $13,000 per year and on average finish in 4.3 years, so they're still spending significantly more at $47,000, $48,000 on their education. And you notice that this was just a mini example, and we are missing a lot of information. There's a lot of things you could think of that are missing from this example. But specifically, notice that we didn't talk at all about variability in the scores, or how there's a lot of variability across individuals, across students, both at Sac State and at UC Davis when it comes to years to graduation or time to graduation. So the next lecture that I do will cover variability. Thank you. Good luck.